Now, I think we can all agree that long division of polynomials is not fun. It is super tedious. And so you might wonder, is there any other way to divide polynomials? And the answer is yes. There's another process, and it's called synthetic division, which I'm going to show you now. So let's take a look at those last two examples that we did by long division and see what it would look like to use synthetic division. Okay, so with synthetic division, what you do is you don't use a long division sign, and instead you just write down the coefficients of the polynomial. So 2, -3, 4, and 5. And then, and this is where you have to remember something a little bit tricky. What you want to put in this box here is the root of this factor. And so the root of this factor is -2. Now, once you're set up like this, then it's pretty much foolproof. All you're going to do is multiply and add and repeat until you're done. So how does this work? You bring down the first number, and then you're going to multiply, add these together, multiply, add these together, multiply, add these together, and then you're done. How do you find your answer out of all of this? This last number here is the remainder, and these numbers here are the coefficients of your answer. So if your original polynomial started with an x cubed, then your answer is going to start with an x squared. So our answer would be 2x squared minus 7x plus 18, and the remainder was -31, which we can write as a fraction over the divisor. Okay, I'm going to show you that one more time. Okay, so what you do is you start off by putting down the coefficients of the polynomial that you're dividing into. In this little half box, you put the root of this divisor. In other words, if you put x plus 2 equals 0, what would x equal? X equals -2. So that's what you're going to put here. And then after that, pretty easy, multiply, add, multiply, add. So bring down the 2. Multiply, add, multiply, and what you're multiplying by is always -2. So -2 times -7 is 14, add, multiply, -2 times 18 is -36, and then add. The last number is your remainder. These numbers here are the coefficients of your answer, and if your original problem had an x cubed in it, your answer starts with an x squared. And that's synthetic division. So it's a lot less writing. Some people might think it's a little easier, but there are some problems with it, which we'll talk about in a little bit. But here, let's try one more example. Let's try a new example. So let's divide 4x cubed plus 10x squared minus 6x minus 20 by x plus 2. All right, so we're going to start by writing down the coefficients of your problem here. In this half box, again, it's the root of this. Now, when you're writing down the coefficients, one of the things you have to check is that all powers of x are present. Because if any are missing, you would have to fill in a coefficient of 0. So when I say all powers of x are present, if it starts with an x cubed, then you have to have a coefficient for x squared, for x, and a constant. Okay? If one of these was missing, we would have to fill in a 0. All right, but now we're all set up. You bring down the first term, you multiply by -2, and then you add. You multiply by -2, and then you add. You multiply by -2, and then you add. Oh, so this one has a remainder of 0. These numbers are the coefficients of your answer. if the original problem started with an x cubed, the answer starts with an x squared. So our answer is 4x squared plus 2x minus 10. We could also check that this was right by doing long division. Why don't we do that? So x plus 2 divided into 4x squared plus 10x, 4x cubed plus 10x squared minus 6x minus 20. All right, what would I multiply x by to get 4x cubed? 4x squared. So we'll multiply. And now we'll subtract. Subtract, remember, means change the signs, and add. This gives us 0, and these two give us 2x squared. We'll bring down the next term. What do I multiply x by to get 2x squared? 2x. If we multiply, we're going to get, let me erase this. I don't want you to think it's a negative sign. If we multiply, we're going to get 2x squared plus 4x. We want to subtract. Subtract means change the signs and add. If we combine these, this is 0, and these give us negative 10x minus 20. What do we multiply x by to get negative 10x? Negative 10. We'll multiply negative 10x minus 20, and you can see that our remainder is 0, and here's our answer, which is the same answer we got with synthetic division. Some cautions, and this is why you have to be super careful, especially when you have synthetic division. What if we wanted to divide x cubed minus 3x plus 2 by x plus 2? So let me just set this up as if we were going to divide it with long division. I'd say, what would I multiply x by to get x cubed? X squared. And now x squared times x is x cubed. X squared times 2x is plus 2x squared. We have a little problem here because these two terms, which are now lined up on top of each other, can't be combined. You can't take negative 3x and subtract 2x squared from it. They're not similar. So whenever you have a situation like this where you're missing a power of x, you have to fill it in. And how would I know I was missing? Well, when you went to do this step, you'd go, wait, I can't take 2x squared away from negative 3x. Oh yeah, it was missing a power of x. So when I set this up, I needed to set it up as x cubed plus no x squareds. There are no x squareds in the problem. Minus 3x plus 2. I had to fill in this missing power of x with a coefficient of 0. Because now, when I go to do the subtraction, x squared times x is x cubed. X squared times 2 is 2x squared. Now I have two similar terms which are lined up. Change the signs, combine these together. These are going to cancel. Here we're going to have negative 2x squared minus 3x, and then we can keep on going. Minus 2x. Negative 2x times x is negative 2x squared. Negative 2x times 2 is negative 4x. We're going to change the signs and add. These are going to cancel. Here we have an x plus 2. This is plus 1, x plus 2, and we have a remainder of 0. Now the caution, really, when we set it up with long division, it's pretty obvious when terms don't line up, and we need to remember to fill in a 0. But if we had done this with synthetic division by writing down our coefficients, and if we hadn't stopped to notice that there was no power of x squared, and we just started off by setting up the synthetic division like this, no way you get the right answer. There's no reminder about that missing term. You can do it synthetically, but you would have to say, all right, there's 1x cubed. Oh, wait, there's no x squareds. There's no x squared. You have to fill in this 0 here before then putting the -3 and the 2 and filling in the -2 here. Then, if you put this 0 here, bring down the 1, multiply, add, multiply, add, multiply, add. You're going to get the same thing, x squared minus 2x plus 1 with a remainder of 0. So both ways come out the same, but with synthetic division, there's not that reminder about filling in the missing power of x. And so if you choose to do things with synthetic division, you have to be super careful about that. All right, so here's one for you to try. So if you want, try it both ways just to practice both techniques. But if you're tired, just pick the one you like better and try that one just to make sure that this is making sense.